Hey everyone, and welcome back to the channel. Today, we're diving into a classic chemistry mystery that often pops up in school labs. Imagine this, you're in a science class, and your teacher points to a jar filled with a mysterious white powder. What is it? How can you figure it out without tasting it? Which, by the way, you should never, ever do. Well, the key lies in understanding the fundamental difference between organic and inorganic substances. It's a concept that's way more interesting than it sounds, I promise. So, what's the big deal with organic versus inorganic? In the world of chemistry, scientists love to categorize things. It's their superpower, and one of the biggest ways they sort all the stuff in the universe is by putting it into one of these two boxes. The main difference comes down to one single, super important element: carbon. Organic substances are the carbon crew. They are compounds that contain carbon atoms, usually bonded to hydrogen atoms. Think of the building blocks of life. Sugar is a great example. You sprinkle it on your cereal, right? That's organic. Starch, which you find in things like potatoes and bread, is also organic. Even the paper this script could be printed on and the plastic bottle on my desk are organic. They all have carbon as their backbone. When you heat these organic guys, they tend to get a little dramatic. They char, turn black, and eventually burn. This is because the carbon bonds are breaking and reacting with oxygen, releasing things like carbon dioxide and water. Now let's talk about the other team, inorganic substances. As you might guess, these are typically substances that do not contain carbon. Think of simple, stable things from the earth. Table salt or sodium chloride is a perfect example. Water, HO, is another one. Metals like iron and copper, all inorganic. These substances are the cool, calm, and collected members of the chemical world. When you heat them up, they don't really panic. Salt might melt if you get it hot enough, and water will boil and turn into steam, but they won't burn or turn black like sugar does. They just kind of handle the heat and stay themselves. Now, chemistry loves to have its exceptions, just to keep us on our toes. Here's a fun one. Carbon dioxide, or CO. It has carbon, right, so it must be organic. Nope. Science has decided it's inorganic. The reasons are a bit complex, but essentially, it doesn't behave like a typical organic compound. So, remember that little quirk. So, let's go back to our initial mystery. The unidentified white powder in the lab. How do you solve the case? You can use this knowledge by carefully heating a small, tiny sample under controlled lab conditions. You can observe its reaction. If it turns black, chars, and gives off smoke, you can be pretty confident you're dealing with an organic substance, like sugar or starch. If it just sits there, maybe melts, but doesn't burn or change color dramatically, it's likely inorganic, like salt. It's a simple, yet powerful test that chemists use. Case solved. And that's the basics of organic versus inorganic chemistry. It's all about carbon and how substances react to heat. Pretty cool, right? I hope this helps you ace your next science test or just makes you look at the world a little differently. Thanks so much for watching. If you enjoyed this video, please give it a thumbs up and subscribe for more science fun. See you in the next one.